strength or the lithology of this flysch deposits is mostly the sandstone and the shale, and they formed during the early orogenic stage by the turbidity currents. Early orogenic means prior to the orogenesis or the mountain building processes. So when when the two plates when the orogenetic process are undergoing within water or underneath the water, these sediment loads which are formed by the as the turbidity currents, they are deposited as these flysch deposits, and they are basically formed by these rapid turbidity currents, and thus these flysch deposits preserve a history of mountain building events and the basin evolution. Why they preserve the history of mountain building events? Because they are mostly formed by only during the orogenetic processes and during the formation of basin. So if we get these flysch deposits somewhere, we can say that in earlier times there was some orogenetic process that has happened, or there was some mountain building process that has happened underneath the sea. They are coarse to medium grained and very poorly sorted. Why they are poorly sorted? Because the turbidity currents have huge gravity flow and the potential to carry the sediments. So that's why sorting is not possible there, because sorting वहाँ पे होगा जहाँ पे it will get time to settle down. Then only the coarser sediment will settle down at the bottom and the finer sediments will be settled at the top in some time. But if there is rapid sediment deposition, it will not be sorted. So these flysch deposits are generally not sorted, and they have repeated layers of sandstone and shale which are linked to different episodic turbidity currents. So these turbidity currents are they do not flow like once they start flowing they will keep on going. So they flow in episodes or in different intervals. So when there is high energy conditions, sandstone will be formed, and when there are low energy condition or lower sediment load of finer particles, then shale will be formed. So depending on the different episodes or of the turbidity currents, these alternative layers of sandstone and shale mostly are formed, and they are collectively known as these flysch deposits. These flysch deposits are often displays incomplete Bauma sequence due to variability in current strength and sediment load. So Bauma sequence is, I will explain in the later slide what Bauma sequence is, but for the time being you just need to remember that it is not a complete Bauma sequence. It is because of the variability in the strength of the sediment carrying capacity. So here is what a complete Bauma sequence look like. So these Bauma sequence are deposited by the turbidity currents, and that's why they are sometimes known as these turbidite sequences. So this have a full here is the full vertical cross section of these Bauma sequences, how they look like. So they have these 5 different layers, succession of these 5 different layers one over the other, how these Bauma sequences are formed. And a complete Bauma sequence consists of 5 divisions which are labeled from A to E, which represent a waning of energy in the turbidity current. This A commonly refers to as normally graded sandstone, as we can see from the picture here that the coarser sandstone particles are settling down at the bottom, so that's the meaning of graded here, and the finer particles are generally present at the top. And then the layer B is made up of parallel and laminated sandstone, we can see here, and then the sequence C is because of the cross laminated sandstone, and then again there is a layer of parallel laminated siltstone. Means the particle size is decreasing as we are moving upwards, and then E is the massive mudstone, the particle size is even finer. So these 5 layered sequences in the same order, if we find at any place, we can say that this is a complete Bauma sequence or the turbidite sequence. But in case of flysch deposits, we are not getting this mudstone deposits. We only get the sandstone and the siltstone, and also we don't get this entire sequence That's why they are known as the incomplete Bauma sequence deposits, which is because of the variability in current strength and sediment load. Here is a picture how they look like in the field. So in earlier times, this sea might have been located somewhere here, and this entire part was submerged within the ocean. But when tectonic activity happened, the sediment load were carried by the turbidity currents. These deposits were formed, and then there was a regression of sea, and when sea level decreased, then these flysch deposits were exposed on this on this field. So that's how they look like. This is the vertical profile, and mostly this is the horizontal profile, how they look like. Okay, समझ में आया flysch deposit क्या होता है? Then the counterpart of it is the mollasse deposits. So mollasse deposits, basically I will come to the previous slide, but firstly we need to locate the difference between these two, and the basic difference is between these two is their orogenic stage. So flysch deposits were mainly forming during the orogenetic processes, but mollasse deposits form after the orogenetic process. Means once there are plates colliding, the mountains have been formed, then mountains erode, and with these sediment load, these mollasse deposits are formed. And they are mainly the sediment load in these mollasse deposits. They are not because of these turbidity currents, rather they are because of the alluvial and the fluvial systems, means the sediment load carried by the rivers. In flysch deposits, we mainly see graded bedding. As we saw in the Bauma sequences, we see shoal marks, but in mollasse deposits, mostly cross bedding ripple marks are seen. And in lithology, the basic difference is the presence of conglomerates in the mollasse deposits, and they are not forming in the deep marine conditions, rather they form in the shallow marine or continental conditions. Why shallow marine conditions? Because mostly these alluvial, because they are alluvial or fluvial system sediment load dominated. So when these rivers carry sediment with themselves, so they mostly deposit them in the shallow marine conditions near to the shore. They cannot go deep within the ocean. So to go deep, the process should be rather interior to the oceans. These exterior fluvial systems cannot go up to very deeper in the oceans. Rather, it should take time. That it should erode from a continental slope to a abyssal plain, and then it will be very like long process. But these deposits needs to be from alluvial and fluvial system. So these mollasse deposits, here is the picture of these mollasse deposits. They are defined as the terrestrial and shallow marine deposits which form near the rising mountain fronts. They consist of various interbedded rock types, mostly conglomerates, sandstone and shells. So conglomerate is the basic difference between a flysch and mollasse deposits. They feature different cross-bedding ripple marks and other shallow water structures. Just a second. हाँ पाठक क्लास ले रहा हूँ, एक करता हूँ थोड़ी देर में ना, ठीक है। हाँ सॉरी, कहाँ था मैं?